So, good morning, everyone. I welcome you warmly to day number 2 of our largest symposium, Economics on the Move, Trends and Challenges from the Natural Sciences. Day 2 is reserved for one important topic, systemic risk. Different from political wisdom, systemic risk does not only occur in finance, but it is also a predominant feature in technical and social systems. If you think of the breakdown of a fiber bundle or of an infrastructure network such as a power grid, then this is to some extent much better understood than the breakdown of a financial transaction network due to the propagation of financial distress. These dynamics, nevertheless, have much in common with percolation phenomena in physics, but also with epidemic spreading in human societies. So the question is, what is the common denominator in these systemic properties? Can economics benefit from formal concepts derived in such disciplines, or are there design principles to prevent systemic risk? These are some of the guiding questions for today, and I very much welcome Mr. Carsten Detken from the European Central Bank, who gives the first talk today.
Okay, thank you very much also for the invitation to participate at this very interesting symposium. I have to stress the small print on the first slide, that these are really my personal opinions and cannot be regarded as opinions of the ECB or the European Central Bank or the Euro system. That's especially important as it will be kind of recorded, this lecture. What I want to do today is just, after a quick motivation, what happened, what we are experiencing at the moment. I think everybody's aware that since the collapse of Lehman, we went through a major recession. It's the worst recession since the 30s. Fiscal deficits are increasing in all countries. Governments have been guaranteeing in Europe, in the EU, or in the EU alone, about 4.5 trillion euro in support of the banking sector. It's not all spent, but I include guarantees here. So this is a major event. It's probably close to 30% of GDP. We have experienced the sovereign debt crisis in Europe. We are currently experiencing redomination risk in the euro area. So these are really major events which I think should motivate everybody to do research in this area and definitely and foster whatever approaches we have, and also the interdisciplinary approach. I'll say more to this later. But what I will do in this 35 minutes or so, I quickly explain you the context, institutional context in which we are working at the ECB in the financial stability area, so that you can see a bit what is our constitutional focus. Present you some examples of the research we are doing, or the progress we are doing in terms of setting up an early warning system for systemic risk. Finally, as a third point, I'll address the general question whether early warning is feasible in the first place, because there's a lot of academic criticism on these approaches, and many people argue you will never be able to predict these crises. So what are you doing here? Why are you wasting your time? I'm trying to give my take on this, and also provide you with a kind of small case study of the last event, crisis. Then finally, I'll comply with what I have been asked to do as every speaker, to say a few words, and perhaps one slide on the need for an interdisciplinary approach. So let me just a few words on the new EU supervisory architecture. And I think here it's important to divide between two lines. One is the microprudential supervision and the macroprudential oversight. Microprudential supervision on the left-hand side has a very important new development, which was released yesterday, was the draft regulation of the European Commission, which will make actually the ECB the European bank supervisor, in cooperation with the existing national supervisors, which are mainly the central banks of the euro area. So this is a very new development. It's proposed so far. There's a draft proposal for regulation, but that regulation is quite advanced, and that's a very important new development in this area. And I will say a few words later why this is so important. On the other hand, which is also new since the start of 2011, we have a new European Systemic Risk Board, which is hosted at the ECB in Frankfurt, but an independent body, which is taking care of macroprudential oversight. The task is here to warn against systemic risks, issue risk warnings, and also macroprudential recommendations. That is a new thing. Macroprudential oversight was a process which was completely neglected before the crisis, and so this in itself is a major event. And here, particular in the area where I'm working, we are providing the quarterly risk assessment to this European Systemic Risk Board as an input to the discussion. It's our task according to the legislation that we have to provide this. So in that sense, we are particularly interested in setting up this early warning system in order to have direct policy influence in the macroprudential process. And that's what I will focus on in the following, because that is working, that's up and running, it's still work in progress, as I will show you, but that is where we have some results and some methodologies developed, and you might be interested in what we're actually using. On the left-hand side, again, this microprudential supervision process is really new, right? So this will have to be set up in a very short time now. The Commission said that we should start already January 2013. And that is, of course, a major task to set up a single European supervisory process in such a short time. Let me just skip the point on, I wanted to have the definition of systemic risk is of course important to start of the day on systemic risk, so I will not bore you with the definition except mentioning one thing is that for us the important issue here is of course the potential of that there's financial stability which becomes so widespread that it really affects real economic growth and welfare. So that is for us the focus of the systemic definition, not necessarily that it's widespread in terms of institutions affected. That could be just potentially could be a very small part of the financial sector. But if it has that effect on the real economy, then we would consider it systemic, and then we are interested in it. To the contrary, really, of this microprudential approach, which I just mentioned, where you really care about the solvency of individual institutions. Okay, so far just for the definition of systemic risk. But one thing which is important is that systemic risk has, of course, two dimensions, as we know. One is the time series dimension of it, where we see the buildup of imbalances, and this creates then the challenge to predict these imbalances, monitor these imbalances in order to provide an early warning model for against this systemic risk materializing. The other thing is the cross-sectional dimension of systemic risk, and here people usually focus on the interconnectedness of intermediaries and infrastructures and markets. So what we will do, I will provide you also with an example. We are interested in both, and we'll try also to combine the elements, like how can we use the knowledge we gain about interconnectedness and from network analysis, for example, for the prediction of systemic risk. That's one of our research focuses. I'll skip some more institutional things, and let me just present you now some examples of recent indicators on systemic risk and also early warning models which we have been developing and which we are actually using at the ECB. One thing is a very simple approach. It's probability of simultaneous default of two or more large euro area banks. This is an indicator based on 15 banks, and this is standard methodology. It's out there. It's the SIMDO methodology from Segoviano. So you start by looking at CDS prices of individual banks, derive individual default probabilities. Then you try to derive the joint probability of default, and finally come up with an indicator which gives you the probability of two or more banks defaulting. And interestingly, here you see that we characterized a few events here. You see that the large increase in these indicators starting in middle of the summer of 2011 was related, or one contributing factor in our view was really the discussion on the Greek private sector involvement, the Greek PSI, where you saw this indicator really shooting up, and markets got really scared about what could happen to banks in case of a Greek debt restructuring. Then you see one line on which we label LTRO towards the end of 2011, where the ECB provided long-term refinancing operations, which supported a strong decline and avoiding and alleviating the perception of refinancing risk in the European banking sector. Finally, now, between April this year and more recently, we've seen again a strong increase in that risk perception of simultaneous defaults, which in a sense was related to redomination risks for the euro in some countries. And again, you see, interestingly, there was this famous speech of Draghi in London, 26th of June, where he mentioned the word that the ECB would take whatever it needs to maintain the euro area, to maintain the euro. And that is indeed had a strong effect on that probability, and CDS prices and correlations adjusted accordingly. There again, I won't go into detail here. It's the Segoviano. I can give you the reference. It's the SIMDO methodology. Computing with the trick here is how do you come up with a joint probability of joint density of default, of course. But perhaps we can talk later. Otherwise, I run terribly out of time. Just as an example of this is standard. This is really standard approaches. It's a bit tricky in terms of computation. We only managed to run it for 15 banks simultaneously. Because it takes quite a while, but otherwise it's standard. Just give you another indicator which has been developed at the ECB. It's called the KISS, Composite Indicator of Systemic Stress, which is a kind of weighted average of stress in different market segments. It's 5 major market segments: forex, money market, bonds, equity, intermediaries. They're all involved here. And here's one innovation, which is that we take into account portfolio theory. In order to weigh to give weight to these different indicators in the different market segments. If you would just forget about this portfolio theory, you would kind of get as a systemic risk indicator I don't know what I have. So it would just be the upper line here. You see the contributions of the different market segments: equity, forex, bond markets, financial sector, money market. And the overall index, if you just weigh them equally, would be the top of those lines because they added up the bars here. Our indicator, this KISS indicator, is the black line. And you see a major difference here and the difference is here that it actually takes into account correlations of different, of volatility and stress in different market segments. And this contribution of the correlation you see actually down here these are the gray bars. Where are they here? Those gray bars are the contributions of the correlations. They were negative in terms of the indicator, so pulling down the indicator in the first phase around the dot-com bubble, because actually there was mainly stress in equity markets and not the other ones. And this is has a positive assessment for risk, in a sense. So it reduces risk. So there were low correlations in the early stage of around the 2000s. But of course, in the more recent phases, around Lehman especially, there is a high correlation of in overall market segments, and that increases risk. So you get a completely different picture when you take into account standard portfolio theory and weighting the different contributions of different the market segments. So far, I was just telling you about these are thermometers, right? You measure the current situation. I will tell you this is actually in the second part. Then I will show you exactly that these indicators are useless for prediction. Right. Let me skip that. Another interesting development, which is really kind of work in progress. It's fresh from the print in a sense. We're trying to evaluate estimate tail dependence networks for European banks. Here we have about the 50 largest banks. in the sample. And what we're doing here is by means of a quantile regression, we're estimating the bank stock return on the VaR exceedances of all other banks, of all other 50 banks. VaR exceedances meaning here that whenever the stock return of a bank is in the 10th percentile, then we give it a 1, so we create an indicator for each bank, and then we are regressing each bank's stock return on these all other banks' VaR exceedances, and then use a quite sophisticated method, lasso. It's called lasso method from Hauch, to select the shrinkage method in order to select the significant contributions. By this, we can try to find the link. So which tail returns are actually linked among banks, where you did see the either by bilateral exposures or by common, this we don't know, of course, or by exposure to common factors, where do we see the co-movements in the left tail distribution of these returns. And interestingly, what you see, for example, here, this is just a general result. If you look on the left-hand side, that's for 2003 to 2007, where, let's say, the more red, the more significant tail returns you find for each bank. And the red dots, for example, are those which have more than 16 significant partners in that sense, partners in crime, and the blue ones are the ones which have no other, where you find no significant linkages. Then you see that during the crisis, the first part of the crisis, this is the middle picture, 2007 to 2010, actually had an increase in the density of that network. Obviously, there were these tail return were much more highly correlated. And then more recently, in the later stage of the crisis, 2010, 2012, let's call it the sovereign debt part of the crisis, you actually saw that the system is getting less dense again. And now you can argue, what do you do with this? Is this a good or a bad thing? Because on the one hand, in terms of network theory, you would say in the recent part of the crisis, the system is less vulnerable, right, than in the first part of the crisis, because it is indeed less dense. On the other hand, of course, this is a reflection of a significant fragmentation of the European financial sector. So banks are really kind of reducing exposures to each other. So that in itself is, of course, a negative development, which you would not like to take comfort of. One interesting thing which we added actually in this methodology, which is, by the way, based, you see the reference here on a paper by Betts and Peltonen in the Directorate of Financial Stability of the ECB, that there's a new thing that we also account in this estimation of the tail dependence. We also take into account of the sovereign bond returns. Because it's obvious that many countries at the moment, or one of the main problems in the banking sector is the dependence of banks on their own sovereign, on the perceived fate of their own sovereign. And if you add that, the picture I just showed, in a sense, is becoming more extreme, that you see on the right-hand side in the most recent period. Once you take away the common exposure to the sovereign, the system is even more fragmented. Which again, I would interpret more at the moment as a negative sign for what is happening in the European banking sector. And these are exactly, of course, the things which this fragmentation, which the European policymakers and public authorities want to overcome by the measures taken, which, for example, has to do with the creation of the banking union. I mentioned it at the beginning, starting with a single supervisory mechanism, with a lot of the non-standard monetary policy measures we have been taking at the ECB as well, and the possibility, for example, to directly refinance banks in program countries via the European Systemic, via the ESM. To the money support to support the principal sovereigns, but potentially also banks in countries under distress. And indeed, here I mentioned Spain. If you just look at this picture for Spain between 2007 and 2010, in red you see the Spanish sovereign, which was in that period completely unconnected to the Spanish banks, which are highlighted on the left side with small es, while in the most recent period you see the sovereign and the bond returns of the sovereign being in the center and being highly connected to the Spanish banks in order to explain their tail returns. So this, I think, is a picture which a method which nicely describes also what's going on. And we will use actually, so this again, this is a thermometer of the current situation. But we will use these estimates of tail dependence in our early warning model in order to see whether actually this adds to predict tail risk events for individual banks. And that's exactly what we're doing here. I'll try to be short on this. So this is one. Now I'm moving from the measurement of just a measurement of systemic risk to the early warning system. So the time series dimension of systemic risk. And what we have been doing here is actually trying to set up an early warning model for individual banks, where it's kind of based on panel regressions for individual banks. We use about 439 EU banks, which have at least 1 billion euro assets. And we calibrate that model to predict 2 years ahead banks in distress. And now here comes a problem for Europe. In Europe, usually banks do not default. And also the defaults since the crisis started in Europe, the number of defaults in the banking system is in the low double digits, while in the US, for example, it exceeds 400. So that's a particularity, of course, in Europe. And so in order to estimate an early warning system for banks, you need to find another measure than bank default. And what is done here is quite interesting and computationally, in a sense, expensive data bank because all the government support measures have been listed. So that we have a data bank where we include actually all government support measures and then can decide when is a bank in distress, which includes when it received government support or stressed mergers and all these kind of things. So I think it's really a kind of innovative left-hand side variable, which is then used and then we attempt to predict that variable. And to do that, we use three types of indicators: bank-specific balance sheet indicators, we use country-specific banking sector indicators, and the authors here use country-specific macro-financial indicators, which are drawn from the EU macroeconomic imbalance procedure, so kind of the official variables used to monitor macroeconomic imbalances. And when you do this, the performance is actually quite good in terms of predictive power. You find kind of the standard signs of different variables. They are again selected by this lasso method, so trying to get around this variable selection bias, which you usually have in this type of in this literature. And let me just very quickly show you an example how it would look like. So there are two examples of two banks, right? So this is for individual banks. So we get warning signals for individual banks here. And so one would be Dexia on the top part of that slide. The blue dotted line here, the thick one, would be when the system provided a warning signal. And the red period is the 2 periods ahead of a distress period. The black line signifies the period where this bank was in distress, which happened repeatedly for Dexia and also for Bank of Ireland, the lower example. And just visually, you see, without looking at the performance measures, you see that actually this indicator's model would have predicted ahead of the distress period the problem of these banks. And really what is relevant here, it's really interesting, it's that really the macroeconomic imbalance measures are important when they interact with the typical balance sheet data like leverage, for example. So these are really key variables here to explain the distress. And it's working relatively fine. And one innovation which the authors have incorporated here is what I said at the beginning. They try to include also this measure of a vulnerability measure with respect to contagion, because what I can do, this is the same picture as I showed you before, but this time for Dexia, which is the red dot. So you can see all the tail dependence of Dexia. So which are the banks which are actually potentially affecting Dexia in case they would get into trouble. And so then you can create this indicator and see whether that indicator helps you to predict whenever one of those banks, which are actually in your tail dependence and close network, in your environment, your neighborhood, in case they get into trouble, this helps to predict the problems of a particular bank. And that also is significant. So that contributes to the predictive performance. You can then derive charts like this, where you actually see the black line would be the optimal threshold. It's all recursively derived. So we're not using any data we would not have had available at each point in time. You see those three components: the bank-specific data, which are in red, balance sheet data; the BSIs, the green thing stands for the characteristics of the banking system in this country, which is not so important. And then you also see the macroeconomic financials in blue, and this would be just for the global systemically important financial institutions in Europe. It's just an example that there would be some banks which actually would get a warning signal at the current point in time. For obvious reasons, I deleted the names from that chart. So third point, of course, which is important, and one could have also started, of course, from this. Otherwise, what I just said would have been not really important. But the general question: is it feasible in the first place to set up a system like this, right? Where those approaches I just presented are part of an early warning system which we're trying to build. Is it conceptually feasible to have an early warning system? Because, as you know, I think majority of academics, at least until the crisis started, I think the mood is changing a bit, but the mainstream was very critical with this type of early warning literature, and partly for good reasons, because I mean there are strong conceptual problems. There's this, we have evidence of terrible out-of-sample failure of these type of models, also based on, for example, estimates around the Asian crisis. When that literature started to boom, so there's this problem of overfitting, of variable selection bias, of choosing those variables exposed after you know what happened in the last crisis. Then, of course, it's relatively easy to come up with an early warning model which nicely explains the recent events. It's a reduced form exercise, so there are a lot of conceptual problems involved here. And it was very difficult to publish any early warning article in the last years. So that's one. And again, these are I think legitimate concerns. Furthermore, I think the majority of policymakers, at least again until the crisis, was, in my view, dominated by fears of type 2 errors, by fears of calling a false alarm. So there was not much appetite to look at or to listen to results of early warning models, because I mean, again here for good reasons. You know, if you would spoil the party, in the end, nobody. This is what people realize, right? That it's you as a policymaker who spoils the party. But the counterfactual would never be. And if you're really successful, and let's say like this: if you're really successful in preventing a boom building up, and contribute to the fact that the boom-bust cycle never happens, nobody will see this. Right? The counterfactual then is not there anymore, so we will not get praised for this. But you will, of course, get praised in case people see if you are the one who bursts the bubble and spoils the party. So in terms of incentive, it's very difficult to I can understand why it was so difficult to find demand for these kind of systems. That, I think, has changed as well. Because now, as I said at the beginning, we know about the costs of potential crisis. Then finally, of course, there's also Goodhart's law, which means that any observed statistical irregularity will tend to collapse once pressure is placed upon it for control purposes. So if, of course, I would use an indicator as a policymaker and fight the building up of imbalances, like some credit growth, obviously what I would do if I'm successful, credit growth would actually be contained, and all the people who then run their regressions will not find anymore any link between that indicator and the occurrence of any boom-bust cycle. So that's also kind of conceptual problem of this whole whole literature, which again, I don't see as a problem in the current situation or in our current exercises, because there has been actually no macroprudential policies, or hardly any macroprudential policies, so we don't need to be too much afraid of Goodhart's law at the current stage, perhaps at a later stage. Okay, why am I carefully optimistic that some of these criticisms are actually not so relevant at the moment? So one thing is what I mentioned is that one can show, actually we have some research showing that if the preference shift actually from type 1 to type 2 areas, so if policymakers become less risk averse against false alarms and become more balanced in their preferences, I mean, this changes actually the indicators, so the best indicators you get out of this signaling literature. So these preferences of policymakers are important, and they by definition they will also increase the usefulness of these early warning models if your preferences are more balanced. Finally, there's a trend towards predicting imbalances rather than crisis. I mean, when exactly a crisis hits, it's very difficult, right? This might be partly also random events, and so early warning models have a hard time predicting those events within a given time horizon. But what can be predicted is actually the imbalances. These are usually more structural, long-term developments. That's much more easier to explain, and that might explain some of the better performances of some of the more recent models. Then there are some more models which are not necessarily high tech, but rather robust and simple non-parametric models like classification and regression tree models, which I think have a high potential in this early warning literature, because they of course can also be easily communicated to policymakers. On data availability, just quickly, of course, there's huge progress in the making. Of course, then there are also interesting methodologies to avoid this problem of overfitting, and also the potential for out-of-sample validation. So people are turning towards evaluating their models out of sample, and have developed methodologies like this Lasso method, which I mentioned, as well as for example, Bayesian model averaging, which can overcome that problem. I'll be very quick on this point, on what I promised on the case study of the crisis. So which type of models would have predicted or would not have predicted the current financial crisis. And here I just distinguish between three types of indicators. First one is what we have just been discussing about, well-specified early warning models, basically focusing on some structural indicators like a global credit gap. The early work of Bill White and Claudio Borrios, of course, very significant here, who promoted these credit gap indicators. And because they're actually, for many crises, they are very simple patterns. Think of the work of Reinhardt and Rogoff as well. They are very simple patterns. It's not true that every crisis is so different. All the systemic events, there's hardly a systemic event which does not come along with a credit boom bust cycle, for example. So focus on the key patterns and derive these structural warning models. Again, I'll show you just one chart soon on a global credit gap. That would have predicted this crisis like many others. Then second, we have a set of structural indicators also, which so far could not really be evaluated in early warning models, mainly due to lack of data availability or longer time series. Housing prices, for example, is a problem for many countries, although they're very important. For financial innovation, for example, we all know that the growth of securitization played a large role in the crisis. But it's very difficult to come up with an early warning model on a new financial instrument where time series are missing. So there you only have these charts where you show some exponentially growing trends, and then you say, okay, is this a risk or not? But with hindsight, you can say so. But in real time, it's very hard to make a judgment on this. And finally, we have all these measures of systemic risk or market price-based models, and they are completely useless in our view for prediction, because they react on the spot. They react when the crisis breaks out. So in terms of time, let me just very quickly show you one example, perhaps each. So this would be one model on what we really use, a global credit gap. Trying to make use of best practices, estimate everything recursively, never use data which were not available in real time at each point in time. Try to derive optimal thresholds for aggregate asset price booms, for costly aggregate asset price booms. So the red line here would be the optimally derived threshold. The blue line is that indicator for a global credit gap. And you see here that, shown by the red dotted line, that in the run-up to the crisis, it would have signaled red. And actually, it's above the threshold between the third quarter of 2005 and the second quarter of 2009, where you would have gotten that warning signal. Overall, I think the performance of these models is not too bad. I mean, you would get kind of 82% of correct warnings, although also 32% of false alarms. So the type 2 errors here are significant. One has to admit that. Just one example of this other type of things, leverage, right? I mean, we all knew that leverage is important, and we have seen, if you just focus on the left-hand side, the leverage where you see the leverage ratio for Euro area and UK banks, it has been rising. But again, it was not at that time, at least, it was not incorporated really in early warning models, and it was very difficult to tell what is too much. Where does the system really become so risky that one would have to do anything? There are a few other examples which I just skipped to in terms of time. Same style, where you see these exponential trends. You see these overvaluations in house price models, for example, but you don't really know what is too much. And then just these two indicators I showed you at the beginning, the joint probability of default of two or more large banks. Here you just see that it's really, this thing is flat and then starts, of course, to go up the moment the crisis hits. So completely useless for predicting systemic stress, and the same more or less for this KISS indicator, which also starts hiking when the crisis hits mid-summer 07. Okay, so let me come to my promise of saying a couple of words on the need for an interdisciplinary approach. And as I'm running out of time, let me be very short here and just look at the kind of summary. For me, in a sense, it's kind of a rhetoric question. I mean, we all know about the deficiencies of mainstream economics. They have become very evident. Economics has always profited from fertilization of other sciences, so it's also that is nothing new in a sense. So for me, and I'm sure many people will say many more details about this. So for me, the answer is clearly yes. So I won't go into the theoretical aspects here. But let me just add perhaps one perspective from my background as a practitioner. Perhaps let me start with the second point here, which is if I think about what we do in my division every day, kind of trying to identify systemic risks for the ESRB, for other purposes. I think what is still missing, although literature is out there, is really to have a close link to the science of uncertainty and psychology, in a sense, in order to avoid a lot of fallacies which are there in the process of risk identification. And I just referred to two recently very well-known books, which are also understandable for the layman like me. One from the Black Swan from Taleb, on what he calls, for example, the ludic fallacy. That thinking about risk, we often forget to think outside the box. We just think obviously about probability and not about true uncertainty. He has this nice example where he has an experiment where he tells you this is a fair coin. I threw it 99 times. It came head was up 99 times. What's the probability that the 100th time it will be head as well? And then he has two people, one kind of a traditional economist and one trader. And the answer from the economist is, of course, I'm not stupid. I know all the events are independent, so of course it's 50% that it's heads. And then the trader says, are you kidding me? You're telling me this is a fair coin? And so that kind of thinking, right? And so I'm afraid sometimes that we are too much in the first type, and I'm thinking about risks too much in the first type of models or of thinking, and forgetting that the rules of the game can change completely. So that's one thing I think in where the science of uncertainty of psychology can have a big effect. The other interesting book I found is from Daniel Kahneman, Slow and Fast Thinking, where again he mentions a lot of things that our inclination to believe our judgment by a heuristic system, what he refers to system 1 heuristics, which is kind of dangerous and incorporates a lot of danger. So there, really for the practical purpose of risk identification in an institution like ours, I think there could be a lot of cross-fertilization, which is important. And another point, and I apologize, I'm not really referring to the natural science, but it's still interdisciplinary. If I think the main, and that goes into the link with political economy and public choice issues, the main systemic risks which materialized during the crisis could, I think, possibly have been contained if there would have been even more closer attention to political-economic arguments in the initial design of the system. And these deficiencies are now dealt with and painfully corrected. Let's think about the setup for public debt of deficits in the monetary union. The problem had been acknowledged, and there was a stability and growth pact to limit deficits, but the way it was set up was politically simply not working, and one had been probably naive, too naive in that sense. So more kind of listening to political sciences plus, so kind of importing into economics from the political sciences, but also exporting economic thinking like it's done in the public choice approach to those people who set up the mechanism would have been helpful. And the same you can say for the financial supervisory process. Also there, I think we have been slightly naive on and ignoring potential failures of national supervisory systems in a union. So there, certainly cross-fertilization is very important. Just to conclude, final slide. I think, as I told you, so in the current macroprudential surveillance process in Europe, the ECB is required to provide a regular risk assessment, risk analysis to the European Systemic Risk Board. This system is established as we speak. It's work in progress, and I try to show you some examples of what we're doing, what we're interested in. Also, the work on microprudential supervisory process has a bright future at the ECB now, but that's only since yesterday. And again, I tried to show you that a careful optimism, that early warning against systemic risk is actually feasible. And I would aim to defend that position, potentially against a lot of academic criticism. And again, let me stop here. Thank you.
Thank you very much. It's time for a few short questions or comments. Mama, please.
So the early warning indicators showed are pretty much based on public data or data which you don't need the central bank access to. So as a central bank or as a regulator, you can have access to a much richer data set. But my impression is that nothing is being done to systematically collect such data. For example, exposures between banks or exposures of banks to other financial institutions, funding channels. So is there any process going on now at the ECB or elsewhere the Systemic Risk Board to systematically collect such a database to enable you to monitor actually something interesting in the future?
Yeah. That is indeed the case. I mean, we don't go so far as in the US, where a lot of has been facilitated by Dodd-Frank legislation. But if you look, for example, if you go on the website of the European Systemic Risk Board, you actually find a lot of initiatives. For example, collecting data on large exposures. There are a lot of initiatives ongoing. I'm hesitant. I don't think they would be available for outside researchers. So I would have to see which of the data collection exercises. But it's done. So there's a lot of effort. That's, I think, was one of my points of careful optimism, was actually the improvement of the data situation. And because I fully agree, right? All we do is publicly available data. Because ECB has so far not been a supervisor. We do not have access to this data. And that, of course, would also, in principle, add to further optimism once we would become the supervisor. Of course, we have to see then with Chinese walls, so which area would be allowed to use that data. But in principle, despite the fact that we use publicly available data, these are still data where the quality of which might significantly improve if we have supervisory data.
Okay, we have a panel discussion right after the coffee break where we can deepen the topic a little bit. So thank you very much again.